Hello, and welcome. Have you ever wondered if a computer could compose a symphony? A piece of music so moving it gives you chills? Well, today, we're breaking down the magic behind how that's not just possible, but it's happening right now.
So let's start with the big question. Can a machine actually compose a hit song? It sounds like something straight out of science fiction, but it's becoming a reality faster than you might think. To really get it, we need to peek under the hood and see how an AI goes from just lines of code to creating an actual melody.
To appreciate just how big a leap this is, we have to look at the old way of doing things, rule-based systems. Think of it like a music box. It can play one beautiful tune, but it can only ever play that one tune. It can't learn, it can't improvise. Deep learning, on the other hand, is like a musician who has listened to and absorbed the entire history of music. It can now create something genuinely new and expressive.
Okay, so if it's not just following a strict set of rules, how in the world does an AI learn something as creative and, human as music? Let's get into it.
It all starts with data, a ton of data. The AI is fed thousands of pieces of music, usually as MIDI files, which are basically digital sheet music. First, it breaks these songs down into long sequences of notes. Then, it turns every single one of those notes into a number. The core of its learning process is actually pretty simple. Given a string of notes, its job is to predict the very next one. It's like playing a massive, never-ending game of finish the tune.
And this is where the real magic happens, in what's called the training loop. Think of it like a student musician practicing for hours and hours. The AI makes a guess about the next note. Then it compares its guess to the actual note from the original music and sees how wrong it was. That error is then sent backward through its system to slightly adjust its internal connections so it can make a better guess next time. Now imagine this happening millions, even billions of times. Eventually it stops guessing and starts actually understanding the patterns of melody, rhythm, and harmony.
But just predicting the next note in a sequence isn't enough to make good music. The AI has to understand the relationships between notes. That's where this brilliant idea called embeddings comes into play. It's really the secret sauce that turns a random sequence into something that feels musical.
Here's how it works. First, every possible note or chord gets its own unique ID number. You can think of it like a secret code. So a C note might be token number 12, a G chord might be 45, and so on. Pretty straightforward, right?
But here's the clever part. That simple number is then transformed into a rich, detailed profile, a multi-dimensional vector. It's like giving each note a set of GPS coordinates in a virtual space. And in this space, notes and chords that sound good together, like C and G, end up being close neighbors. This creates a sort of musical map. So the AI isn't just seeing random numbers anymore, it's seeing the relationships and the landscape of the music itself.
So that's how it learns. But what about the learner itself? Let's dive into the different kinds of AI brains, or models, that actually do all this work.
There are three main types you'll hear about, and honestly, the story of how they've evolved is all about memory. The early models, called RNNs, had terrible short-term memory. They could only remember the last few notes they saw. Then came LSTMs, which were a huge improvement, able to remember longer patterns. But the real game changer today are transformers, which can see and understand the entire song all at once.
LSTMs were such a breakthrough because they have this clever internal system of gates. You can imagine a little gatekeeper inside the AI's memory. It has one gate that decides which old information is no longer relevant and should be forgotten, and another gate that decides what new information is important enough to remember. This lets the model hold onto a song's main theme for a much longer time, which leads to way more coherent music.
And that brings us to transformers. This was the next giant leap. Instead of processing a song one note at a time like the earlier models, a transformer looks at the entire piece of music at the same time. It sees the beginning, middle, and end all in one go. This gives it this incredible global understanding of the song's structure, allowing it to build really complex and cohesive compositions.
But what's really interesting is that the biggest, most powerful tool isn't always the best one for the job. Transformers are incredibly data-hungry. They need massive music libraries to learn effectively. So if you're trying to train an AI on a more niche style, like, say, 12th century folk music where you don't have a ton of examples, a more focused model like an LSTM can actually give you better results.
All right, so this stuff isn't just happening in a research lab somewhere. Let's talk about how this technology is actually being used out in the real world right now.
A perfect example of this in action is a platform called Amper Music.
Basically, it's an AI composer that lives in the cloud, ready to create custom music for anyone, whether you're a YouTuber, a business, or just someone making a home video.
And using it is incredibly simple. You don't need to know anything about music theory. You just tell it what you want. You could say, I need a happy, upbeat folk song that's 2 minutes long. And the AI gets to work. It generates the melody, the harmony, the rhythm, the whole shebang. And in just a few moments, you get a completely original, high-quality audio track that's totally royalty-free.
You can see how this is an absolute game changer for content creators. Anyone making a corporate video or a social media post can instantly get the perfect background music. It completely takes away the massive headache of dealing with music licensing and the fear of getting a copyright strike.
So, with all this amazing progress, it brings up a big question. Where is all this heading? What does the future of making music even look like?
Well, the future probably isn't about AI replacing human artists. It's about AI collaborating with them. We're talking about tools that can generate music, lyrics, and video all from a single prompt. Or think about a soundtrack that can adapt in real time to your mood. This is about partnership, not replacement.
And that, right there, is the most exciting part. This idea of a true creative fusion. A duet between one human and one AI. The human brings the vision, the emotion, the spark of an idea, and the AI acts as this incredible, tireless collaborator, suggesting harmonies and rhythms a person might never have even thought of.
Which leaves us with one final fascinating thought. This really changes our definition of creativity. It's not just about what a person can create anymore, but what a person and an AI can create together. What kind of art, what new genres, what incredible sounds will be born from that partnership? The possibilities are, well, endless.